Okay, so we're going to look at some characteristics of graphs of logarithmic functions. So a logarithmic function, if b is greater than 1, it's going to look something like this. Something like that, okay? So the domain is going to go from 0 to infinity. The range, the outputs, the outputs are going to be all real numbers. Now, why can't I include the 0? Well, because if you remember in the exponential function, it never touches the x-axis. And so that's what we're going to get there. We can't ever have that logarithm equaling 0. When we have b to some exponent, that's not going to equal 0. Okay? In order to have that, you'd have to have a 0 that was the base. The base would have to be 0, and we're not allowed to have that in our exponential functions or in our logarithmic functions. Okay, so that's that. They all go through this point right here, which is the point 1, 0. Think again about the exponential function. It went through the point 0, 1. So when we switch those, switch x and y, we get a common point that's going through 1, 0. Okay, this is what the function looks like when b is greater than 1, and that is an increasing function everywhere. It's increasing from negative infinity, from, you'd go by the domain, from 0 to infinity. It's increasing. Okay, but what if b is between 0 and 1? Well, if you remember, that function looked like this. Okay, so the only difference, those other things still hold true. The domain's the same, the range is the same, goes through the common point 1, 0, but this is a decreasing function. From 0 to infinity. Okay, and then the asymptote, well, it was the x-axis on an exponential function. So for a logarithmic function, it's the y-axis. Or x equals 0. So if you want the equation for the asymptote, it's x equals 0. And that is right here. I'll put it in a different color. It's right there. Okay, that's the asymptote. All right, those are characteristics then of logarithmic functions. They're graphs. I should put characteristics of graphs of logarithmic